pick it up with the exercises, but the things I talked about last time, the key components. Posture dictates muscle function. Remember that phrase. What does that mean? The alignment of how you place your body when you put it under load, in particularly, dictates the muscle firing patterns, the contractions, the amount of force. And I used the harness example. Remember I showed you L4 and L5? And I showed you how muscles line up based on your posture and alignment. And when you line up in a neutral spine, with the shoulders external rotation, the hips and external rotation, that arch in the back, the way the muscles attach on the spine totally dictates the orientation of the muscle fiber alignment. So when you bend over and there's a huge load on your spine, and you have this shear force, we talked about shear forces, one vertebrae slipping, the direction of your muscle fibers, particularly the erector, in neutral is on a 45-degree angle, maybe even a little better. So they have a great angle of pull to counter that shear force. As soon as you go into a rounded posture, the alignment of the muscle goes north-south. So visualize trying to support the vertebrae from falling forward with the angle of pull like this. And we did the analogy with the harness, remember? And I had, who was it, Wendy playing L4 and I was the erector. And I tried to support her with a north-south pull, and there's no way. She's going to fall forward. Where does that load go? On the disc, that shear force, okay? Now this is not just with the muscles of the spine, it's every muscle in the body. When you have someone do a pull or a push, the alignment, the shoulder force, that's why you can manual muscle test someone, test them in this position, push down their arm, and they'll give. You put them in external rotation, then the fiber alignment of the rotator cuff, the scapula stabilizers, all come into a nice angle of pull to create force output. So you can dictate strength simply by alignment. And that's why power lifter, Olympic lifters, they spend hours upon hours, sprinters, working on their alignment so they can maximize force output through the skeletal system. Sprinters do it with the force being speed. Parts of Olympic and power lifters do it more with the force being strength and power. Does that make sense? So as trainers and PTs, we have the ability to create powerful athletes, both from a rehab perspective and a training perspective. On the other end of the spectrum, we have the ability to destroy bodies. Because a lot of the reasons people come, more so in the training world than the PT world, because the PT world, the focus is on a rehab component. But in training, a lot of what people come to training for is what? Vanity, the way they look. Well, you can make someone look good on the outside, right? You can build their arms up and tone them while doing what to the inside? Destroying it. You know, if we don't use the rules of physics and biomechanics properly, yeah, we can get them ripped, we can get short-term gain, but it's at the expense of the inside breaking down. Then years later, back pain, hip pain, etc. So, you know, we have incredible power in the way we dictate our training programs and functions to create solid, like, alignment and stabilize bodies or to destabilize bodies. So let's review that briefly. I talked about Boyle, I talked about McGill. Shirley Sarman is the one I didn't talk about. Shirley Sarman has done amazing work in the field of PT, but it's been transferred over into the training world. And Shirley's primary thing was, if you had appropriate mobility in one area of your body, particularly your hips, you spare the spine. Quite simply, you have to have a certain amount of hip flexion to move freely. Sprinters know this. If you don't have that hip flexion, where's the compensation come? The lumbar spine. And it's the same with rotational patterns, and she'll take you through all these rotational motions, and in everyday life it's like this, but if you don't have enough rotation in the hip, where does it come? In the lumbar spine. Okay? And I talked about how you get about total, depending on the reference you use, 7 to 15 degrees of total rotation through the lumbar spine, with motions occurring at this L5, S1 junction. Depending again on the reference, it can be anywhere from 4 or 5 degrees to 7. Then 2 or 3 degrees at the other segment, maybe a degree. But it's about 15 max, 10 degrees depending on the resource. So there's not a lot of rotation that comes through the lumbar spine. So if you over-rotate the lumbar spine, where does that load go? What has to bear that load? The outer layer of the disc, the annulus, and that's how we start putting grips in it, like a tire tread. Okay? Now there's a big difference between putting forces through the spine under load and under non-load. So that's the question I get all the time. Does that mean we're never supposed to move the lumbar spine? And the answer is no. You have to understand the difference between loaded movements and unloaded movements. So in unloaded movements, both with flexion and rotation, this is an unloaded movement. So we're maximizing flexion and extension through the lumbar spine. And you can even, under non-loaded movements, do side bending, You know, you see things like this in yoga, non-loaded movements. And even in standing, if it's, and again, it depends what the margin of safety is on the person. If you have someone who's got a severe deteriorated spine, disc injury, pathology, back pain, you get a much smaller margin of safety. So even when the movement's supported and unloaded, they still might not tolerate this. You know, that causes pain. This causes, so you have to work within their tolerance. And there's a lot of variables, right? What does their stability level look like? What does their spine look like? What does their endurance look like? They might be able to do 2 or 3 reps like this, and then they get pain because they don't have the stabilization over endurance. So a lot of variables to look at. They don't have the coordination. In standing, we let's visualize if I have a stick that doesn't weigh anything. Then this is a stick. So, sorry. Or, you know, in the yoga class, we see things like this, right? A side bend motion. And you can see the motion should be, if the focus is unloaded and a range of motion, it should be equally distributed through the vertebrae. What we don't want to see is a hitch like this. This is where you get inequality of motion. But we want to see a nice symmetrical side bend through the entire spine. Now again, this is an unloaded movement. So this is okay, preferably if you're trying to achieve range of motion, to create an opening, a gapping of the right side of the facets. Trying to open each facet equally. It's a range of motion exercise, which shouldn't be confused with a blueprint under load. So let's, for example, I'm carrying a suitcase, or I want to teach someone to kick a suitcase up. I can pick up this, visualize this as a 100-pound suitcase. If I apply this principle of side bending with a 100-pound suitcase, is that safe? No. No. Because where's that load going to go through? Through the disc. Remember, the margin of safety goes way down when you load the spine out of neutral. As soon as I take the extreme of side bending in, I might add some flexion. This is not the blueprint we want to establish from picking up a 100-pound weight. This is a loaded movement. This is a range of motion movement, unloaded. Does that make sense? Now again, some people, there's even unloaded movements. Say someone's got a bad disc injury or bad back, they don't even get away with an unloaded movement without hurting themselves, because even the smallest of loads destabilizes them. Does that make sense? So you have to know who you're working with. In PT, we have people, there's no way we're going to have them go to the extreme of side bend motion because they're going to destabilize them. So they might just work gentle side bend range of motion within their tolerance. But anything that's loaded, even remotely, and the load is different for everyone. What's heavy for one person is not heavy for another, but the blueprint should always be the same. Neutral spine, because neutral spine has the alignment of the muscle fibers and the nervous system activity to maximize force output and unstabilize the spine, or excuse me, to provide maximum stability to the spine. So the blueprint should be this. Hip hinge, minimal reach, but watch when I reach, is my spine side bend. See the hinge? Very little side bend. So this is how we have to teach people to move. The difference being, one is like this, and one is a shift. See, with the spine staying in neutral. See the difference? This is the shift. See it? And that requires what? Back to Sherman's one. What does it take to do this? The hip range of motion. So if your clients don't have the hip range of motion to hinge and squat and reach like this, what do they have to do to pick that suitcase up? Side bend, under load. Their margin of safety just went way down. Shear force is good for the spine. That's the connection between hip mobility and spine stability. So we always have to make sure we have the hip mobility before we start loading spines with lifting patterns. Make sense? Okay. And it's not just lifting. How about in the gym? You can just visualize a viper. And you see this exercise done in the gym quite a bit. Visualize this as a stick. Emphasis, it weighs 1 pound. Person's got fair stability. They can emphasize what? Side bending through. Okay? Now let's say it's a 40-pound viper. Do I want to see this pattern or this pattern? See the difference in the pattern? One, the spine is locked in neutral with a side bend force. One, see the difference? Now, why do people tend to do exercises like this under load? Because they're bodybuilding. They're thinking, I'm building obliques. Okay, this should be, the building of the development of the side stabilization muscle should be a byproduct of the movement, not the goal. And that's always been what's the word? The the criticism on bodybuilding. It creates poor blueprints at the expense of what? We can vanity-wise try to build muscle and make someone look good, even though we know there's no such thing as fat-specific burning, but this is not a blueprint we want to create under load. Unloaded maybe, to try to create range of motion like you might in yoga, but not under load. And if we're changing a blueprint to lift heavy weight, or get stronger, the blueprint should be brace, neutral spine, side bend, locking the spine down, not creating a lot of mobility through the spine. See the difference? Rib trainer, same thing. We don't want to see this. Granted, this, yes, this is a light load, so this could be done for range of motion, right? There's the side bend. But if I'm really firing up heavy resistance, see the difference? One, the spine is locked, one, I'm trying to gap it. Depends on the load. And then that's where your professional experience comes in. Where does it cross the boundary between range of motion and trying to get some range versus load on the spine and the safety involved? And this comes with experience and time, and, you know, where you think your clients fall in. But never, it should never be about doing side bending with load to build obliques. That is the worst thought process at all. I mean, the oblique development is the byproduct of the blueprint, which should be the correct blueprint. Okay? Comments or anything? Okay, so with that in mind, and again, motion should always be controlled before it's produced, and I'll talk about that with rotation. So with new clients in particular, even patients, you know, one of the mistakes we might make is teaching people trying to produce rotational force without doing what? Learning to control rotational force. The control of the movement should always precede the production of the movement, regardless of it. Side bend, same thing. This should be preceded by what? This. Control of motion, production of motion. Control of motion always precedes production of motion, especially at fast, high velocities. Why is it sometimes we tend to jump to the high-speed explosive stuff? Again, we're trying to fat burn, we're trying to produce muscle. We go back to that bodybuilding mentality, and we all do it. We're thinking about, you know, how can we build muscle development, but we have to be thinking on the other end of the spectrum, probably first, how do we create good blueprints of controlling forces on the body, and then produce force on top of that. Control precedes force production. Okay? Control, then production of the force, whether it's rotation, side bend, or extension, flexion. Let's see, we want to go into the exercise sequence yet? Just quick review, defining stability. Because again, this is something when we all start talking to each other, we want to be on the same page. Stability, simple term for stability, best term I believe, the ability to control joint alignment. Doesn't matter what the joint is. In the case of the spine, it's several joints. If you do a squat and your back defaults into this position, you are not controlling joint alignment. If you do a squat and your back defers into this position, you are not controlling joint alignment. Okay? Now again, you have to go back to the concept I talked about with load and unload. If someone does a squat, you're teaching them to do a squat, and at the bottom they round a little bit, you might be willing to say, okay, I'll let them fall out and be a little unstable in the spine to try to increase hip mobility. I'm willing to give up a little spine stability to have a little bit more hip mobility. And it's unloaded, right? So I can do that to say, okay, I'll let them round their back a little bit, but I'm doing it to try to get something else. So this is where experience comes in again, but we understand what the variables are, because we all agree that we don't want to put 100 pounds on their back under a loaded situation and say, okay, I'm going to let them go lower than they have the ability to maintain spine stability, get hip mobility, because what's the difference? Huge amounts of load through the spine. This is how we hurt people. So under load, they have to hold neutral spine. Where you draw the line between what is load and unload is 10 pounds, 20. You know, you have to use your best experience on that. But obviously, the heavier you go within their ability, the more you need to be aware of neutral spine, because neutral spine, under positions of movement, is stability, core stability. Okay? It's the same with any joint. It doesn't matter if it's the shoulder, does the humeral head roll forward or backwards? When do they use it to go overhead? If it does, you've lost stability. You've lost the ability to control joint alignment. So core stability is just the ability to maintain the alignment of your curves under load, particularly is where we want to challenge you. What do the muscles do? The muscles all act as brakes in different directions depending on their origin and insertion. They stabilize the spine so it can't fall out of neutral position, either hyperextension-wise or hyperflexion-wise, or side bend-wise, or rotation. The muscles are brakes, so if there's a force on the spine that comes at it quickly, a linebacker hitting a quarterback, bam. Can you maintain the stability of the spine, or does the spine default into an extension-rotation pattern, a flexion pattern, an extension? Any direction that that spine defaults results in what? A loss of power output through the distal extremity. Remember, everything flows upstream or downstream from the core. Or, well, and I should say, a shear force or a rotational force or a compressive force that does what? Breaks the disc down, facet down, etc. So this is why we slowly progress loads on the spine in different directions, why we challenge it to maintain stability. That's why we do planks and side planks with the hope that it's going to transfer over. Okay, so enough practical talk. I think we might want to exercise now. Let me get okay, so why doesn't everyone go? The question I always get is, what is the parallel question in all professions? Pilates, yoga, physical therapy, training. Where should the spine be set on the back? And I'll give you my perspective on that based on the work of a lot of different people. And it depends on what you're starting with. Because the question I always get is, if I put someone in this position, where do I want their spine to be? Should I have them pushing into the floor? Should I have them arching? The one thing, again, we all agree on, the agreement in the field is, the most stable spine position is a slight arch in the back. So you can call, well, let's say, what is a slight arch? Put a hand under the back, okay? It's approximately 10 degrees, 15 degrees is typical we see in the references. It's a slight arch. Now let's say you have a gymnast, you know, who has a huge spine arch like this, and they lie on their back, and their back looks like that. Which direction do we want the spine to go? Towards the floor. Do we want it to go all the way to where it's flat on the floor? No, you want a slight arch. It's that simple. So if you put your hand under the back and you say, press down and push into my hand slightly, don't smash my hand, that's the direction you want to go. If you have someone like a lot of guys as they get older have the flat back posture, they've lost their curves, and they're lying on their back, and their back is flat on the floor. You put a little towel or your hand under there, raise the spine ever so gently, and they have a slight arch. Then you teach them how to lock that in. Get a feel of what it feels like to have a slight arch in your back. That's the position you want them to achieve. Now, so does that make sense? That's the position of greatest stability. Once they can maintain that position, then you have to teach them how to lock it in. And this is where a little debate goes, but you know, there's the debate, do you suck the navel in or do you brace? Okay? I don't like the suck the navel in theory. We've talked about that in detail. I've used it. I've used ultrasound to watch it. I like the work in McGill much better. Bracing, where you co-contract multiple muscle groups, which is, it's very much like doing a quad set. Tighten the quad, and we know when you tighten the quad, what happens to knee joint motion. What happens to all that translation of the tibia and the femur when you tighten the quad? It's reduced dramatically. It's the same rule with the back. When you brace the abs, the amount of translation, shearing forces minimizes dramatically. So you teach them how to find neutral, and you have them use their hands. If it's a hyperextended spine, they have to push down. If it's flat back, they got to go up. Then they brace and they lock into it. Most people who've got back issues or have hyper spines out of it, they lost the proprioceptive feel of what that feels like a long time ago. They have no idea where neutral is. Because their neuroreceptors have been out of position for so long, when you tell them that's neutral, they're like, that feels flat, or that. You have to retrain neutral spine. And you do that on the back best. And using their hands gives them great proprioceptive feedback to feel that. Then it's just a function of there. Once they can maintain that, then you start doing what? Moving the extremities while they maintain it. They learn how to find neutral as there's motion occurring. And then combination patterns, you know, the dying bug. That's it, that's the progression. Can they maintain neutral and stability while an extremity moves? Then that has to be transferred into standing eventually, right? Can they maintain neutral while an extremity moves? You know, can they maintain neutral while can they maintain neutral with a hinge? Everything has to transfer into standing in a little way. Okay, make sense? You'd be surprised. You tip them on their back, you teach them neutral. As soon as you teach this, what happens? Back defaults to hyperextension or hyperflexion. You have them reach, back defaults to hyperextension, rotate. They have to learn how to maintain neutral with the extremities moving. Okay? So that's the sequence on the back. Then, of course, you know, for gluteal re-education, how do the glutes come in? The glutes help. If someone's got the hyperextending spine, the glutes can help move the spine into the correct position. And that's where we lead into bridging. And they may use the glutes to assist in maintaining the neutral spine without pelvic tilting. That's where the bridge comes in. Okay, so now I'm going to switch gears. Those are basic ABCs. Every athlete I work with, patient-wise, regardless of the injury, they have to learn to do that before I even get to their injury. If they have Achilles tendonitis, that's what I look at first. Shoulder impingement, that's what I look at first. Because if they can't set the spine, everything's going to default into a poor pattern. Everything starts central and moves out. So that's everything begins there.
So you start people on the floor, have the maybe like a single or single arm movement.
Yeah.
And
yeah. Someone's got shoulder impingement, and they find neutral here, maintain it, and then eventually, you know, we look at all the shoulder patterns, flexion, and turn.
And then I assume you add another limb after that.
Yeah. Yep.
And then
It's all
at what point do you go to standing? How do you make that fall? Is there a tell for you?
No. Well, keeping in mind they're going to stand regardless, right? Because they're going to have to go. So I'll teach them basics of standing, but no, it's like a child development. You know, there's the quadruped sequence. We'll get into some of this today. Side sequence, stomach sequence, but they're going to walk out the door, so they're going to have to stand. You know, they're not like a child where they're going to stay crawling until they progress into. So they're already instant. You just have to teach them standing alignment, external rotation, which is all this, and you just teach them to start standing like this. Females get out of this habit. Hips way this way, there's out of neutral spine.
I stand that way too.
Yeah, you know, that's about here. You know, guys here, or whatever it is. But if everyone could do this 5 minutes off and on through the day, they'll find neutral much quicker, and they'll start enhancing that neuromuscular process to hold neutral spine. Then can you hold this and through the day do this? Yeah, you change the pattern, and then you load it eventually. So let's go through the anti-brakes, meaning the anti-motions. So what we're teaching with the core is how to prevent rotation, side bend, etc. So let me start in the side bend pattern. So the side bend pattern, and I'll take you through the work with different guys, Boyle. We've got different patterns. The problem I see with the side pattern, what do we typically use to create side stabilization? Which exercise? We use side plank, right? Yeah, so this is a typical start position, right? And this is a plank. The problem with this is, as soon as I load, what position am I in? I'm already side bent. See it? So I'm under a side bend position. As soon as I lift, there's a contraction force through the spine with a side bend. So I'm creating a blueprint to do what? Teach them how to load with side bending. This is not how I want to pick the suitcase up. So switch the side plank to a side bridge. Watch what I'm going to start with. I'm going to start them in a hip flexion pattern, a hip hinge. See the difference? Now I got the neutral spine. Now when I come up, is my spine side bend right now? Very little, because I'm in hip hinge. The dominance of motion is coming from where? The hip. Now when I come up, I come into hip extension. See the difference? Thrust, back is still locked. I can put my hand here. When I go down, do I go down like this in the side bend, or hip flexion? Hip flexion. Where's the bias of motion? On the hip joint. This is a bridge. It's just a side bridge. So get rid of the word side plank, put in side bridge. Okay, then you can add progression. What are progressions? Let me go closer. You know, I mean, these are advanced progressions, but this is one of Boyle's ones that he's a big fan of. You know, things like this. And then when you're really strong, you know, but again, a lot of people create bad alignment where? See it? Defaulted in my neck. The head has to stay neutral because the neck is part of the spine, so you have to be looking straight. This can't be defaulting here or here, so you got to correct the neck posture. Just like a sprinter, you would never let a sprinter run with their head down because they're defaulted to a rounded spine. Up, chest up. Thoracic extension, set the core, engage the lat, which will stabilize the spine before you come up, then add the hip extension thrust. And then you can load it on one leg, etc., etc. Those are all progressions. Does that make sense? Big difference between a side bend bridge and a side plank. I mean, excuse me, you know what I mean, a side bridge with a hip extension thrust. You want to create the hip extension thrust, not the side bend torque. Now, if you want to create side bend range of motion for a rope, this is fine, right? but I'm not going to plank. I'm just using side bending to create motion. Now, this is an unloaded movement. Okay, nothing wrong with this, right? Now, if I want to come up from here, though, as an exercise, and we see this done a lot, it should be what? Bracing. The fulcrum of motion should be where? The hip. It's this, like gymnasts do. Not side crunching like this. It's up. See the difference? Teaching the side bend pattern where this is all locked and stabilized, because remember, core stabilization brakes are on. This, not this under load. You guys get what I mean, right?
So you're thinking about initiating at the hip.
Well, locking at the back,
Locking the back.
locking at the spine,
Yeah,
and then creating the motion through the hip.
through the hip.
Yeah.
It's kind of the same principle that you were talking about earlier, where if you're lacking hip
Yeah.
mobility, what's jeopardized? The back.
Yeah.
So we want to initiate, I think.
Yeah. So it takes a much more strength to do that as well. Okay, so back to the suitcase carry. So now here's the pattern, functional wise, right? Functional meaning make it into a purposeful movement for everyday life. Well, here's your side plank, right? There's the shift. See it, side bend? But I'm not side bending like this. It's a shift, more weight on this side, take some hip mobility, up. Okay? Now I've got a side bend force that's isometrically being contracted by the brakes on this side. Okay, and it could be this. Eventually what? Walking, holding the posture, walking the floor. Back to the other concept of external rotating, locking the shoulder girdle in. Progressing to this stuff, side bend force, fighting that rotation. Those are all side bend anti-brake patterns, right? We're trying to create an anti-side bend force, lateral flexion force. Okay. So that covers side bending, and there's other ones, there's tons of ones, but I'm giving you 3 or 4 basic progressions to think about, okay? Let's do rotation. Rotation is probably the one we see most of, where most people, like Sarah is a perfect example, Sarah Broomer, trainer Sarah. Her issue is anti-rotation. She can't maintain rotational control, that's why her back's always buckling out when she does snowboarding or something. One rotational torque, bam, the spine goes. So it needs work on the ability to control rotation. So what are the rotation sequences? Well, there's lots of them. Let's start with you guys on rotation. Okay, well, again, when we're talking about rotation, remember, when we talk about core stability, we've got multiple muscle groups that are contributing. No one muscle group contributes more than 30%. We've got the muscles in the back, the erector, we've got the side ones, the front ones. So from an anti-extension perspective, the most basic one is the vertebra. Because by doing this exercise and teaching people how to push into the floor, externally rotate, lock the shoulder girdle, so I'm applying this rotational torque, maintaining spine position here, and then lifting the leg up with the core braced, I'm trying to teach them how to fight this rotational pattern defaulting into this, overcompensating, where the spine is completely neutral. This is hard for a lot of people. And then they can progress to this. Usually what we see is it's done way too fast, and there's no pre-calibration. So it's locking, external rotation. Can you maintain the neutral spine without defaulting into an arch or a rotational pattern? And if you do this correctly, this is a very hard exercise. Stabilizing, pulling in, holding. If you don't feel a major contraction and you're not fatigued after 10 seconds here, you're just going through the motions. And then you stay with the same side, slide down, 10-second holds. You do 3 or 4 like that. After 3 or 4 reps, you should be burning in the spine. I mean, not the spine, but the muscles that support the spine, if that's done correctly. Now, McGill's progression to that, which I like a lot, is he does this. He says when they can do that, which very few people can do right away, I find, they're always a compensation pattern, he goes through the squares with them. He likes the idea of a fist, because the fist engages motor unit recruitment. He's thinking about stabilizing through the scapula. Bam, can they maintain spine stability? Square. See the square? Watch spines. Very few people can do that without maintaining stability. They default either to a rotated spine or an arched spine, but they can't maintain spine stability. So try that square pattern with them, but most people won't start there. Most people will need to start with a leg, maybe an arm and then a combination. But most people don't get the maximum benefit of the bird dog, which is a super powerful exercise to control rotation. Now on the other end of the spectrum, that's the bias on the back. And of course we have it this way as well, right? External rotation. Can they maintain spine stability, or do they default? If you want to make it easier, wider, closer. This is one of the most basic ones to control rotation. Control play. Most people can't do that well without some form of compensation. Okay? When they can master, some basic patterns there with the rotational control. This is Boyle, a lot of Boyle stuff now. Boyle will progress them up the chain, meaning they go from a position on the floor to a half kneel position. And he has the lift and the chop. This is the position with the rear leg in the back. They have to lock into this position. Glutes, external rotation front leg, and it's just basically a pull. It's a lift pattern like this. The chop pattern is high to low, same thing. But the key is to control the rotation first. It's not this. That's a production of rotation force. It's controlling. And the rear glute's the key, I find. You gotta lock it. So it's this. Make sense? It's locking it in so there's no rotation. And then you do the other side, of course. You can play with different angles. Then you can change positions, of course. Now you got a punch pattern. This works with the rib trainer as well, right? Can you control the rotation with a pushing force in the half kneel position? Can you control the rotation facing it for more attention? Okay, and then of course progressing the scanning positions. Can you control the rotation? Rib trainer allows what? A longer lever arm, so the force is way out here. Can you control that rotation while you push and pull? Now, McGill does this whole exercise sequence to teach how to steer from the hips, which leads into, we can talk about this next time more. He has this whole pattern. Teach them to plank like this, stabilize. Can they learn to turn as a unit? Well, this is all locked. Turning as a unit, pivoting. Or most people, what you'll find is they lead like where? Upper body rotation and the hips follow. What happens when that occurs? You get the rotational torque. So he teaches that pattern in detail where everything has to steer as a unit. That's the rotational sequence that everyone should master before they produce force with rib trainers or cables. Make sense? Anything else on rotation I want to discuss? Those are some progressions that emphasize rotation. And I think the next lecture, that's what we're going to make it, rotation. It's going to be all about rotation. Forces that go through the spine, how to control them at different angles. Because when you lift a suitcase off the floor with a rotational force, it's a completely different force and direction than if you're up here and you're doing rib trainer exercises. Versus if you do it on a Roman chair. There's different rotational forces depending on angles, and that'll probably be the next lecture. Extension flexion. That's probably the most basic one we usually start with. I save it for last. So obviously, if we're trying to prevent the back from going into hyperextension, we start with the plank, right? Now again, the key with the plank is that we teach it properly first, where the people are bracing, pushing their heels together, squeezing the glutes, pulling the elbows in, then coming up. So we have the pre-activation and calibration before they move. 10-second, 20-second holds, and then down. Maybe let the knees go first so the back doesn't do what? Collapse into hyperextension. So here, knees, stable. Then you can go down. Glutes, up a little bit. There's your hip hinge. Up. As opposed to just bam. Hyperextension, coming out of hyperextension, teaching the neutral, bracing, holding, and then come up. So that would be the extension force here. Progression. Okay, so you have choices. You just visualize you have towels or the Reebok board. Okay, so and this can be TRX as well. Yeah, the balance slides. So this could be TRX as well. I'm just going to teach you the slides. So same concept, starting on the knees, right? There's the brace. Okay, this is just upper body moving. Remember, it's upper body, maintaining neutral. There's the chin tuck. Can they pull back, or do they default into a flex spine? That's the nice thing of the TRX. It does have a nice move to it. Okay. Reverse side. What Sorel's on is you notice. Okay. Resetting. Remember, push, extra rotation of the shoulders. Resetting. Where there's a hip hinge pattern and not a flexion extension pattern. All can be done with the TRX, the suspension trainer, of course, as we know. And then the most advanced one, and Boyle saves this one for last in his progression, is where the whole body becomes a lever arm. And you see things like, this is the hardest one, because it's the whole body lever. Or does it shift forward or back? Usually, you have to be really strong or you default into an arch position. In terms of the spectrum, that's the hardest. So you do isolate arms, isolate legs, then the whole connection together, the whole body is a lever arm system. That would be, you could do it on the Reebok as well. And of course, there's 50,000 other variations you can progress into, right? Okay, so that's some of the work of Boyle's progression. What I like what McGill does is, his point is everything has to come into standing eventually, because the patterns of equilibrium, Gambetta shows this as well. The core firing pattern in this position is completely different than this position, which is a functional, purposeful position of going upstairs, whatever. So some progressions in standing would be, we have the double leg ones. This is where you learn how to hinge correctly, the hinge patterns, the shoulder patterns, and then basic lifting patterns, while you maintain spine stability. Hinging overhead, maintaining spine stability, which is a completely different core firing pattern than when you go single leg. Here's the single leg pattern. There's a couple single leg ones that are really good. So you have to, again, go back to that extra rotation, stabilize, up, down, core activation, shoulders back,